Hello guys, in this video I am going to explain the solution of this question 28A of chapter 7 from this book Engineering Circuit Analysis by Hayt, Kemmerly and David. So the question is that the circuit is given and it is saying that we need to assume that the circuit has been connected for a very long time and we need to determine the value of each current labeled Ix. Means we need to determine the value of Ix. So in this type of a question, since it is mentioned that the circuit is in this position from a very long time, so it simply means that the current through like the voltage through the inductor, it will be zero. That is, we need to replace the inductor with short circuit. With short circuit. Just a minute. Yes. Similarly, about the capacitor. Okay, we do not have the capacitor, but if we have the capacitor, then the current through the capacitor, it will be zero, and it means that the capacitor will be replaced with the open circuit, right? So it means that if the circuit is connected and it is in this state for a very long time, then the inductor can be replaced with a short circuit and the capacitor can be replaced with the open circuit. So using this concept, we can redraw this particular circuit, and redrawing this particular circuit, simply we will replace all these three inductors with a short circuit. So our circuit in that case, it will be like this. It is 16K, it is 4.7K, then again 4.7K, and then we have this 7K, and then again we need to short circuit it. So this will be the circuit that we will obtain, after short circuiting all these three inductors. And this is the Ix current, so this is our Ix, right? Now simply by using any theorem, we can get the value of Ix. So over here, let me use the, it is 10 volt, let me use the nodal analysis. So let this is the A node, this is B node, and let B is the reference node. It means that the node voltage B will be 0 volt. So applying the KCL, if I write a current equation for this, then it will be VA minus 10 upon 16. For this, it will be VA upon 4.7. For this one, it will be again VA upon 4.7. And for this one, it will be VA upon 7 equal to 0. And remember, in the denominator, this is K. So even if we convert it into ohm by placing this 10 into 10 cross 3. Now this 10 cross 3, 10 power 3, we need to put in each denominator, right? And since since on the right side we have 0, so it will be cancelled out. So it is the reason I have not put this 10 power 3. Now solving this, if you solve this particular thing, so you will get the value of VA as 0.99066 volt, right? So near to 1 volt. It is near to 1 volt. And now since we need to determine this Ix and this Ix and this Ix, it is the current in this particular branch. So this current, it will be considering node A. So this current will be VA upon 7K, right? So Ix, this is Ix. So our Ix, it is VA upon 7K. So it is like, so VA is this. So it is 0.99066 upon 7 milliamperes, or if we will get 0.141524 microampere, or sorry, milliampere. It is milliampere, and we can write it as this. this is answer to this particular question. So if you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.